Action potential by Talia Besser. Neurons, like any other cell, are negatively charged on the inside and positively charged on the outside. When it is like this, it's at resting potential. They have the capability of generating action potentials, which makes them an excitable membrane. At resting potential, the membrane is at negative 70 millivolts and the voltage gates are closed. There are many sodium ions outside the cell and many potassium ions inside the cell. When a ligand binds to a voltage-gated sodium ion channel, it allows sodium from the extracellular to rush into the intercellular. Now within the cell there is an influx of sodium ions and will continue to do this until it has reached membrane permeability. The sodium ion channel is now known as the activation gate, and the potassium channel is known as the inactivation gate because it is closed. When sodium is rushing in, it is known as the absolute refractory period. The membrane cannot respond to more stimulation, and this is also known as the depolarization stage. When sodium rushes in, it causes an electrical charge and will be sent down when the threshold reaches negative 55. Repolarization begins when sodium channels are closed and voltage-gated potassium channels open. Potassium ions move out of the cell, and now there's an efflux of potassium ions. Once potassium ions have reached permeability, both the sodium and potassium channels close. The cell now is hyperpolarized. The sodium-potassium pump will begin to activate and pump out 3 sodium ions and bring in 2 potassium ions. It will continue to do this until it has reached the polarized state. And that is how action potential works.